So in GeoGebra, I like to use GeoGebra Classic only because um, I think the tools are a little bit easier to use. So I want to stay in coordinates. This is what Desmos seems to kind of lack in the geometry part is this clear connection between coordinates and geometry. So I'm going to draw a figure. And again, I tend to like the letter F only because it's easier to tell what's happening here. And then a dilation requires an object to dilate, which is this letter F, and it also requires a point. So I'm going to place a point here. And what I will do is that the dilation tools are underneath these transformation tools. So down at the bottom, I can dilate from a point, and I need to select on the object. So I'll select on the inside of the F, and I will select point K. And then for my factor, my dilation factor, I'm going to place N, and that's going to be a slider for me. So I'll create a slider, and that slider goes up here, probably at the probably goes, there it is, right up here at the top. I'm going to click on this to show it, and I'm going to make this a little bit smaller. So what I can do is now the students can kind of drag around this slider to change the size of the image. So when n is larger than 1, my image is larger than the original image. And when it's negative, it flips upside down. And I would ask kids, what kind of a transformation then this is this when I make it a -1? And when my dilation factor is a -1, this is just a 180-degree rotation around K. Honestly, kids just need to play with this. They need to see these different scale factors, and they need to move K around to notice what happens. Now, I also understand that it is probably going to be easier to probably do this with a triangle instead. So let me see if I can make this with a triangle. Oh my goodness gracious. I would really like to select everything, but I can't without moving it. So I'm just going to draw another triangle. So I'll draw this triangle here. And I will put a point down there. And then I'll go to my dilate tool, select the triangle, select the point, and place point N. And now a triangle, again, there's fewer points, so it might be easier to see some things. When I drag point O around and put it right there on the top of N, I could discuss the mid-segment theorem, which I believe you might have done already. I've got nested triangles here. Is it possible to ever get one triangle exactly on top of another, or for example, L prime on top of L? And that does happen when my center of dilation is there. So this is what you can do with GeoGebra. Kids need to be able to play. They need to be able to drag this around so they can get a feel for how these transformations work. And what you're doing then is you're creating that conceptual hook for kids to hang their new learning on. So you can always refer them back. Remember when we dragged O around, or remember how the slider changed our scale factor. When our scale factor was greater than 0, our image grew by 60%. When it was less than 1, it shrunk by 70% in that case. So for example, that's that. Have at